Rohit was looking out of the window while traveling by train. To him, the roadside trees appeared to be moving backwards. At the same time, fellow passengers in the train appeared at rest even though they were moving with the speed of the train. When the train stopped at a station, he observed people moving on the platform, hawkers with their carts moving here and there. He experienced that the train in which he was sitting appeared to move while it was at rest, but in fact, a train on the neighboring platform was departing. He could not find the reason related to it. Can you help him find the answer? Let us continue with this chapter and find out the answer to some more similar questions. Motion of an object. We also see different objects in motion in our everyday life. Examples are related to visible and invisible motion. The motions visible to us are our own movements, flights of birds, motion of vehicles, motion of fans, etc. We can easily perceive these motions, but we are unable to perceive motions like flow of blood through our veins and arteries, etc., though we can experience it. An object may appear to be moving for one person and stationary for some other. It means that motion is a relative concept. For example, if you are sitting in a car and another car is moving with the same velocity beside you, and if you look at that car, you will feel you are not moving. A body is said to be in motion if it changes its position with respect to its surroundings and is said to be at rest if it does not change its position with respect to its surroundings. We are able to perceive the movements of birds and the movements of hands of a clock. We cannot perceive the movement of air during a cyclone. Displacement and velocity. Ram is on his way to Shyam's house. As it is Shyam's birthday, Ram has to buy a nice gift for Shyam from the gift store, which is 5 kilometers east from Ram's house. After buying the gift, Ram travels 12 kilometers north to Shyam's house. The total distance travelled by Ram is 5 plus 12, that is 17 kilometers. If Ram has to go directly to Shyam's house, how much distance would he need to travel? We can find this answer using Pythagoras' theorem, as the distances travelled by Ram are perpendicular to each other. Let us name Ram's house as X, the gift shop as Y, and Shyam's house as Z. Therefore, according to Pythagoras' theorem, we have xz squared is equal to xy squared plus yz squared. Therefore, xz squared is equal to 5 squared plus 12 squared. Therefore, xz squared is equal to 25 plus 144. Therefore, xz squared is equal to 169. After taking the square root on both the sides, we have length xz is equal to square root of 169, that is 13. So, the shortest distance is the direct path from Ram's house to Shyam's house, that is 13 kilometers. So, distance is the actual path followed by a body between the points in which it moves. Displacement is the shortest distance between the initial and final points of movement. This image shows lines for distance travelled and for displacement. The distance covered by a body in unit time is called speed. Speed is equal to total distance travelled divided by total time taken. The SI unit of speed is meter per second. CGS unit of speed is centimeter per second. 1 kilometer per hour is equal to 1000 meters divided by 60 seconds multiplied by 60 seconds. The distance travelled by a body in a given direction in unit time is called velocity. It is the rate of change of displacement with respect to time. Velocity is equal to displacement divided by time. Units of velocity and speed are the same. Speed is related to distance, while velocity is related to displacement. In simple terms, velocity is the speed with an associated direction. Speed is just how fast you are traveling, whereas velocity includes the direction in which you are traveling. The magnitude of velocity and speed will be equal if motion is along a straight line path. In other cases, magnitude of speed is greater than magnitude of velocity. As velocity is related to speed and direction, it can be changed by 1. Changing the speed and keeping direction same. 2. Changing direction and keeping speed constant. 3. Changing both speed as well as direction of motion. Uniform and non-uniform motion along a straight line. The motion in which the object covers equal distances in equal intervals of time is uniform motion. The motion in which the object covers unequal distances in equal intervals of time is non-uniform motion. Example, motion of vehicles on a crowded street. Acceleration. Pedal your bicycle starting from rest and attain maximum velocity in few minutes. If you see your friend in the path, apply brakes. The bicycle stops after becoming slow. In the entire case, velocity does not remain constant. The rate of changing of velocity is called acceleration. Acceleration is equal to change in velocity divided by time. If u is the initial velocity, v is final velocity in time interval t, then a is equal to v minus u divided by t. This kind of motion is accelerated motion. When body is at rest at the start of motion, initial velocity u is equal to 0. When body comes to rest at the end of motion, then final velocity v is equal to 0. Most bodies possess two types of accelerations. First is if there are equal changes in velocity of body in equal intervals of time, then it possesses uniform acceleration. An example of an object having uniform acceleration would be a ball rolling down an inclined surface. The ball picks up velocity as it goes down the inclined surface with equal changes in time. The second one is if there are unequal changes in equal intervals of time, then it possesses non-uniform acceleration. Acceleration of a body may be positive or negative. When velocity of a body increases, acceleration is positive. Here, acceleration is in the direction of velocity. When velocity of a body decreases, acceleration is negative. Negative acceleration is also called deceleration or retardation. It is opposite to direction of velocity. Zero acceleration is related to uniform motion.